Hey guys, this is part 3 of the platformer tutorial. So in this part, we're going to be creating the player class. Well, actually, we're going to be creating the MapObject class, which I will use as the superclass for all objects in the game, basically. So just a recap of what we did last time. Again, we created the game state manager with the menu state, and we started working on level 1. Right now it's just a blank screen with the tile map in the background. We can actually set the background here before we start. Back in level 1 state, we can add a new background, private background, BG. And over in init, again, is where we initialize all of our stuff. BG is equal to new background, and I put the background for level 1 over here. Yep, so it's in /backgrounds/grass bg1.gif. Okay, oh right, and we need to give it a move scale, and I set it to 0.1, so it moves at 10% the tile map speed, basically, and we have to draw that. So we no longer have to clear the screen here, just draw background, which is just bg.drawg. Cool. And let's see if that's working. Okay, there's the background. So now we can actually get started with the player class. So I'm going to create a new package in source called entity. This is where all of the objects are going to go, all the class objects, object classes, I mean. Okay, I'm getting something here. I've never used main.game panel. I guess I can get rid of that. I have a warning here. Alright, so I finally figured out how to suppress warnings. It's suppress warnings and then serial. There we go, and that should suppress the warning. That was in game panel, by the way. It was complaining about something about serializable classes not having an ID. Anyway, that's that for game panel. So in entity, the package entity, we can create the superclass MapObject. This is basically the root of all game objects that we will use. And again, this is an abstract class. We don't want to use MapObject itself. We want to extend off of it. Players, enemies, projectiles, stuff like that, they will all be map objects. So we all need a tile map, and let's import that. Tilemap. There we go. And we need a I'm just gonna set these for the tile stuff. We need an int tile size. Oops. Since this is an abstract superclass, everything has to be protected so that the subclasses can actually see these. And the map position. Okay, let me move this down a little bit. So we have the tile stuff, we have position and vector here, protected. Y, X and Y, and DX and DY. So again, X and Y position, DX and DY, the direction it's going, the object is going. And we need some dimensions, width and height. This is mainly, just for, the width and height is mainly just for reading in the sprite sheets that we'll use. The real width and height, I call them, they're part of the collision box here, that I call them C width and C height for collision width and collision height. these are what we will use to determine collision with tiles and other enemies. So it's like these are the real dimensions, I guess. Anyway, so other collision stuff goes down here. These are just variables that so we don't have to keep making new ones. This is current row that we're in, and the current column that we're in, and some destination where we will be going. This is the next position. X destination, Y destination. We also need some temporary stuff. Temporary position. And now I always, again, I'm using the 4-point method for collision, using the 4 corners to determine whether or not I'm hitting a block tiler or not. So I'm going to use that here at top left with 4 corners, top right. These are all booleans. Bottom left and bottom right. And we also need some animation stuff. Protected animation. We don't have an animation class yet, but we will be making that soon. Protected int. We also need some kind of current action to tell us which animation we're currently using. And possibly previous action. I'm not sure how useful previous action is going to be, but we'll keep it there just in case we need it. We also need some movement. This is basically, these are like booleans that determine what the object is actually doing. So we have left, which means it's going left, right, up, oops, down, and we have jumping, oops, boolean, I mean, and falling, and actually we could put up here an animation, another boolean called facing right, because it's part of basically facing right is used to determine whether or not the sprite should be facing right or facing left. And if it's facing right, then we don't do anything with it. If it's facing left, we have to flip the sprite over so it's facing the other way. So that's that animation movement. What else do we need? We need movement attributes. These are like the physics or whatever. Like move speed, how fast does the object accelerate? Max speed, how fast the object can go. Protected double. And stop speed, this is the deceleration speed. If you're not pressing left or right, then this is the speed, this is the value that your speed decrements by. So what else do we need? We need fall speed. This is like gravity. And we also need max fall speed. This is like the terminal velocity. We need jump start. This is how high the object can jump. And I have this mechanic where if you hold the jump button for longer, then you keep going higher, and if you only hold the jump button for a short amount of time, you don't jump as high. So I also have a jump stop jump speed. And that should be it. Every mapped object has all of these fields, which is kind of a lot. So that, and I put everything under this one superclass so that I don't have to keep reusing these over and over. Like when I make a player class, I need all of these, and when I make an enemy class, I also need all of these. So everything just goes into the map object, basically. So now we can do the constructor. Map object all the constructor will do is, I don't even know I have a constructor here. It's abstract. I guess I can keep it in here. Because all this basically does is set the tile map and get the tile size. That's all the constructor does, basically. Anyway, so we need our basic stuff here. Every map object needs to be able to check if it can collide with other map objects, and that's what this function is for. Intersects map object other. And here I use just rectangle collision. So like rectangle R1 is this rectangle, the rectangle for this object, which is again I'm using C width and C height. Int y, C height, and C width and C height. And rectangle 2 is the other object's rectangle. I should probably use get rectangle function, but that's up to you. If you guys want to create a public rectangle, get rectangle that does this for you. I guess I can actually do that. Return new rectangle. So this is a new function here. Rectangle doesn't exist. That's weird. It's in java.auth. So let's go all the way to the top and import that. Java.auth.rectangle. So go all the way back down here, and we have a function public rectangle get rectangle. Returns new rectangle. It's basically this. So I'm just going to copy and paste. Oops. There we go. So return a new rectangle like that. And all I need to do is rectangle R1 equals get rectangle. And rectangle R2 is o.getRectangle. So that's pretty much that. Then I can just return here R1.intersects R2. Oops. R1. And that will tell me if these two map objects have collided. This is useful for like projectiles, like when I'm doing the fireball thing and I'm hitting other enemies. I have to use the intersects function. So that's that. Let's go ahead and do the tile map. Again, this is the superclass. All objects have these functions. All map objects are going to have these functions. Let's see, public void check tile map collision. This is going to check whether or not we have run into a blocked tile or a normal tile. So first we need to find out what what row and column we're on. Get column tile. Oops, that doesn't exist. So it's actually just int x divided by tile size, and the current row is column is x, right? Yeah, columns goes across. Okay, tile size. So these are current column and row, and we need the destination. Plus equals dx and plus equals dy. These are the destination positions. And we also need a temp value in order to keep track of the original x and y, because we will be making final changes to x and y using xtemp and xy. So calculate corners x and y dest. Again, calculate corners is the 4-corner method for determining tile collision. So up here, let's create the calculate corners function. I guess this could be let's make it public. Calculate corners double x and double y. And first we need to find out the left, top, right, and bottom tiles. So the left tile is just, again, it's x minus c width divided by 2, divided by tile size. Ooh. So it's pretty much trying to find this, except I have to shift it, the collision width divided by 2 to get the left side. This is the current column, and this is like the column on the left side of you. And we also need the right side. So this is x plus c width divided by 2. And we're going to do minus 1 so we don't step over into the next column. And top tile is pretty much the same except in the y direction. So y minus c height this time, divided by tile size. And bottom tile, same thing. Y minus, except it's plus c height divided by 2. And again, minus 1, we don't want to go downwards into the next tile. So that's the left, right, top, and bottom. Now we can actually figure out the types. Int t top left is TL. Tile map dot get type. Top tile, and left tile. And we're gonna do this for all 4 corners. Top right, top tile, and right tile. And the bottom left is tile map dot get type. Bottom tile and left tile. And the bottom right is tile map dot get type, bottom tile, and right tile. Okay. Oops. Bottom tile. Forgot tile up here. Okay. There we go. So now we have the 4 corners, top left, top right, bottom left, bottom right, and we have the type of tile that those corners have come into contact with, and now we can actually set the 4 booleans that we had at the top. Top left is equal to T1 is blocked, like that. Oops, it's not T1, it's TL, Oh, we can't see tile. So let's go all the way to the top and import that. So import tilemap.tile. There we go. Where was I? Right, calculate corners. So that's top left is pretty much just a top left tile. Check if it's blocked. Top right, same thing. And this is TR equals tile.blocked. And bottom left equals B bottom left tile.blocked. And bottom right is equal to BR equals tile.blocked. Okay, so now we have the 4 booleans. Like for example, if we were going up left and we hit a wall, if we were jumping up to the left and we hit the wall, top left would be set to true because the top left corner is blocked, and we would have to do stuff like stop the player from going top left or something. So that's that. So first we calculate corners in the y direction. We're now back down here to check tile map collision. So if dy is less than 0, this is in the y direction. So if we were headed left, then we have to check if the left corners, this is dy, right? We're checking the dy direction first, y destination, and dy is less than 0 means we're going upwards. So since we're going upwards, we have to check the top 2 tiles. So top left or top right. Not the top 2 tiles, the top 2 corners. So if either of these are set, excuse me, then we have to stop moving in the up direction, and we have to set the object just below the tile that it just hit. And that's at current row times tile map.getTop. I don't even need that. I have the tile size already. Plus c height divided by 2. This will set us right below the tile that we just bumped our head into. And the other one is if we are going downwards. If dy is greater than 0, then we have landed on a tile. And again, we have to check the bottom two corners, bottom left or bottom right. Then we have to stop the y direction, and if we were falling, then we have to set falling to false. We're not falling anymore. We've hit the ground. And we have to set the y position to just 1 pixel above where we just landed. Basically right above the tile that we just landed on. And this is current row plus 1 times tile size divided by c height. Minus c height divided by 2. So that's that. Otherwise, oh, I forgot. Here, if we go back up here, if dy is less than 0, means we're going upwards. If top left or top right, means we've hit something or had hit something. Then we need to stop. Otherwise, we are free to keep going. Y temp plus equals dy. We can keep going upwards. Nothing stopping us. There aren't any tiles. And likewise, if we're going down, if we're falling, if we've hit a tile, then we have to stop. Otherwise, we can keep falling. So y temp plus equals dy. So that's that for the y direction. Now we can actually calculate corners for the x direction. It doesn't really matter which direction you do it first. You can do x first, then y, but it doesn't matter. So we're doing the x direction now, x destination and y. So if dx is less than 0, that means we're going left, and again we have to check the left corners, which is top left and bottom left. And that if either of these are true, that means we've hit a blocked tile and we have to stop moving. Dx is 0, and we have to set the x position to just right of the tile that we just hit. And that's current column times tile size plus c width divided by 2. Otherwise, we're free to keep going in that direction. X temp plus equals dy. I mean dx. Said dy. Anyway, the other direction is pretty much the same. If dx is greater than 0, then that means we are moving to the right. That means we have to check the two right corners, top right and bottom right. If either of these are set, then that means we've hit a wall to the right and we have to stop moving and set our x position just to the left of that wall. And this is current column plus 1 times tile size minus c width divided by 2. So that's that. And the last thing we have to do is we have to check whether or not we just ran off of a cliff. And we're going to do that. If we're not falling, then we have to calculate corners for x, y destination, plus 1. We have to check the ground 1 pixel below our feet and make sure we didn't fall off a cliff or anything. If not bottom left and not bottom right, that means we're no longer standing on solid ground and we have to start falling. So that's pretty much that for check tile map collision. So I guess we can go into the other functions. What else? We can actually create a bunch of getters here. Public int get x, return int x, getters for y. Also get getters for the width and height. Get width, return width, public int get height, return height, and we can also use getters for the collision width and collision height. So c width and c height. Get c height, return c height. Alright. We also could use a function for setting the position. Public void set position, double x, double y. And that's just going to set our x and y to these values. So these are setters. set vector. This.dx is dx, this.dy is dy. And also set map position. This is very important. Every map object has two different positions. One is the global position, which is the regular x and y. The other is their local position, which is their x and y position minus plus the tile map position. So like this, we have to set the x map and y map accordingly. So again, these two are very, very important. The regular position and the map position. Because the map position tells us where to actually draw the character. Like if our player was at position like 2000, 1000, then he would be off the screen. We have to find out how far the tile map has moved in order to offset the player back onto the screen, and that's the final position: x plus x map, y plus y map. So that's that. We also need to have a way to set the actions for the object. Public void set left, boolean b, left equals b, and this is pretty much for all of them. Set right, boolean b, right equals b. Oh, I can't type. Set up. Why do I keep typing return? Set down. Down equals b. There we go. We can also have one for jumping. Boolean b, jumping is b. There we go. And that's pretty much it for that. Oh, I have one more function that's very important. Just like the tile map, where when we draw the tile map, we don't draw the entire tile map every single time. We only draw the tiles that are necessary. Again, with MapObject, we don't want to have to draw map objects that are not even on the screen. There's no point. So, this function is going to return a boolean, true or false, whether or not the object is actually on the screen. We're going to use this to determine whether or not we have to draw the object at all. So on screen, return, and this is just simple, x plus x map. Again, x plus x map is the final position of the player on the game screen itself. So the position and the map position, very important. Plus width divided by is less than 0, or x plus x map minus width is greater than game panel dot width. So if the object is wait, this is the wrong direction. This is more like I'm doing it not on screen. So okay, so let's change the function name to not on screen. So if the object is beyond the left side of the screen, or the object is beyond the right side of the screen, or the object is below the screen, on top of the screen, above the top of the screen, and or the object is what do you call it? Below the bottom of the screen. Game panel dot height. Then we have to return true, or we can just return this whole thing here, pretty much. So this returns whether or not the map object is on the screen. Wow, that took a long time. That's pretty much it for MapObject. Ooh, that's 30 minutes. I'm gonna stop this video here, and I'm going to actually create the player in the next one. So I'll see you then.